Hello friends, welcome to Alankar Pharmacy classes again. Today I am going to tell you one of the very important topic that is related to flow of fluid, and this is Reynolds number and its significance. So without wasting our time, let's start. Now Reynolds number is initially introduced by Sir George Stokes in 1851, but at that time this concept is not known as Reynolds number. And later on, this concept was popularized by Osborne Reynolds by publishing his research in some very prominent journals at that time in 1883. And later on, another scientist name is Arnold Sommerfeld. He named this concept as a Reynolds number, and nowadays this concept is known as Reynolds number. Now, what is this Reynolds number? This Reynolds number is a dimensionless number to understand the pattern of fluid's behavior during its flow. Now, it is represented by this Re, and it determines whether the fluid flow is laminar or turbulent. Now, this Re is actually a ratio of inertial to viscous forces. Now, what are these forces? These inertial forces moves liquid in forward direction, but these viscous forces tries to resist the motion of the liquid. So, in this way, both the forces acts in the opposite direction, and the ratio of these both forces is the Reynolds number. And if we if we keep the flow of the liquid, if we keep the flow rate of the liquid less, then most likely the flow of liquid will be laminar, because in that case viscous forces will be dominant. But if we increase the flow rate, then later on these inertial forces will become dominant, and this flow rate will be turbulent. So there may be a change in the flow of fluid from laminar to turbulent, and turbulent to laminar depends upon which kind of forces are more dominant in the flow of fluid. Now, as we have already discussed, this Reynolds number equals to inertial forces divided by viscous forces. So by this we have derived actually the two different equations. Both the equations are applicable. So first equation is the rho multiplied by V multiplied by L divided by this mu, and another equation of the Reynolds number calculation is rho multiplied by V multiplied by D divided by rho. Now this L here stands for the length, and this equation will be applicable when the fluid is flowing through plate. In fluid mechanics, we are performing some experiments in which fluid may be flow through plate, and in such cases this equation 1 will be applicable. Now otherwise, if it is flowing through any pipe, then in this case this D stands for the diameter will be applicable. So using these both equations we can calculate the Reynolds number of any liquid. Now this rho stands for the density of the fluid. Now this V stands for the velocity of the fluid. L is that we have already discussed, this L and D, and divided by this mu is the viscosity of the fluid. Now this Reynolds number help us to determine whether the flow of liquid is laminar or turbulent. So if it is laminar in nature, Reynolds number that should be up to 2100. Now if it is turbulent, then Reynolds number figure will be more than 4000. Now there is a transition flow in this both type of flows, that is between 2100 to 4000, and this is the transition flow. Suppose if there is any fluid which is flowing through any pipe and it is having a Reynolds number equals to 2500, that means the flow is transition flow. So in this way we can calculate, or we can understand what kind of flow that any fluid is showing. Now, as far as its applications are concerned, there are many pharmaceutical industries who are based on the liquid formulations. So, in those industries, this Reynolds number concept help us to understand the flow characteristic of the water or solvents that are used to prepare any such kind of products. And also there are some industries who are which are preparing some sort of fluid in which there are some particles also, for example suspensions. So if the particles are flowing in an orderly manner along with liquid, and this is actually possible when there is a laminar flow. Otherwise, if there is a turbulent flow, particles are also flow in a disorderly fashion, and this will create problems in further processing. So, understanding the concept of this Reynolds number there, we can solve some sort of engineering problems to prepare our products of a good quality. So, this is the overall applications and concept of the Reynolds number. So I hope you all have liked my video. Please share with your colleagues or classmates who are in the search of this topic, and I am also providing the link of all of my previous videos in the description box. So please go through those videos also. So thank you friends. Thank you.